Let's build. Today we're going to be using LangGraph to build this workflow. It allows us to build a graph-like workflow where we can run different tasks and connect them through edges and nodes, wherein a node basically runs a task and an edge connects two different nodes together. Now, our task is to make this graph structure wherein essentially you're going to start and there's going to be a router which will, using the operation variable or operation2 variable, it will either pick the addition operation or the subtraction operation, these two edges, because they're connecting these two nodes together. And so it'll pick either or one of these edges, and based off of that you will either go to add node or subtract node, run the respective logic, and move on to the next router, which will do the exact same thing again, but now for different variables, specifically the number 3, number 4 variable, and the specific operation for it. So you can either add these variables or subtract these variables. All right, and then within the logic of add node, subtract node for both of them, add node version 1, add node version 2, subtract node version 1, subtract node version 2. For either or, you will respectively add that result into final number and final number 2. And that's what we will output out. Okay, so now that you have a rundown of how this will sort of work, let's actually build the system. So, first things first, I'm just going to add a markdown file where I'm going to say building conditional graph logic, like so. Okay. All right, first of all, we need to import our utilities or libraries, and specifically we need the typed dictionary, and we also need from LangGraph.graph the state graph, which will allow us to actually build out this graph, and then the start and end, which are the start and end node. So it just makes it really easy to define the start and end. Cool, let's go ahead and run this logic. Shouldn't be too hard. All right, now we'll move on to actually defining the schema. And the schema will be for the state. Remember, the state is essentially the collective information that is shared, right? This information is shared throughout different nodes and is used within these nodes and modified within these nodes. So, we need to define what different data is required within the state. And so you can name this like schema whatever you want. I prefer naming it agent state because that's exactly what it is, right? You're building AI agents using LangGraph presumably, and this is basically defining the different data, like the different variables, information that goes into building the state. We're going to pass in type dict over here, and then now we can go ahead and define exactly what data is required to make this work. And that's essentially all of this information, right? Because all of this information is used in one of these nodes and modified or is passed through it. So number 1 is going to be an integer. Then we're going to have operation, which is going to be a string. Number 2, which is going to be an integer. Number 3, which is going to be an integer. Operation 2, which is going to be a string. And I misspelled number 3. And then we're going to have number 4, which is a integer. Final, and actually to make it a little bit organized, I'll put number 1 and number 2 together, and then the operation afterwards, and that will follow suit for this. like so. And then now you're going to have your final number, which is an integer, and then a final number of 2, which is also an integer. All right, perfect. Let's go ahead and run this. Good to go. All right, moving on, we now need to actually define the functions. So the function is going to be add node 1. So this is for the logic of our first node of add node. All right, we're going to also make the logic of this as well as the router. So within here, we're going to need a docustring, and that docustring can just say this will add number 1 and number 2. And then we can update the state. So we actually need to pass the state in first as a parameter, and that's again going to be the state that is being shared, right? So this is the syntax for allowing that to be passed, and then this is basically just saying, hey, this function will output a state as well, which it will, because we're going to update it, and so LangGraph needs it updated, which will happen when you return something from this node. So the state is just going to be final number in this case, because this is for node 1, right? And that's going to be just adding the 2 numbers. Remember, this is a dictionary, so that's why I can use the syntax. And it's going to be like this. Oops. Very simple. And now we can just go ahead and return that state. That's done. Okay, let's move on and just build the same logic, but for subtracting now. So again, we want to pass in that state because we're going to be using it. You always pass in that state for any sort of function that is being used within nodes. And this will subtract number 1 and number 2, right? So then we're again going to call final number. But in this case, number 1 is going to subtract with number 2. It's fine if it produces a negative result. Now finally, we're going to need some sort of logic for the router, right? You can call it whatever you want. I'm going to call it decide next node 1, because that's exactly what it does, right? This node basically decides whether you go to this node or this node. And in this case, we're also going to pass in the state, but we're not actually going to be using the state at all. Okay. Now, I'm going to call in a docustring so we can just define what this function does. And this node is just going to select the next node. Very simple. Very self-explanatory from the function's definition. And so this is where we're going to use the state of operation and seeing whether that is an addition or a subtraction. And if it's this, we're actually going to just return a string. And the string is going to be whatever you want, but in my case, I'm going to say addition operation. And we're going to see later on when we're actually building out the graph. Because right now, we're only just making the logic which is going to be used in the nodes of the graph. But once we actually start building the graph using the state graph class in LangGraph, you'll see how this comes into play. So now I'm going to do the same thing for subtraction. And in this case, it's just going to return subtraction operation. Cool. This is done. All the logic is done for these 3 nodes. Now I'm just going to do the same thing for these 3. It's just a repeat of what I've done over here. But all that changes are like the variables. So what I'm going to do is I'm going to run this, and then I'm going to create a new code block. I'm going to copy all of this. I'm just going to modify the function definition a bit. So instead of node 1, it's going to be node 2 for all of them.
I'm not quite sure how to help you with that.
Sorry about that. That's my Alexa. Okay, cool. Now, I'm just gonna go ahead and update all of the number 1s to number 3s, right? Or yeah, number 3s, because that's the state or the variable that we're now looking at. And exactly the same thing for number 2s, they're going to be swapped for number 4s, because remember, for add node 2 and subtract node 2, we're going to be using the number 3 as well as number 4. And then the final number is going to be final number 2, right? It's going to be operation 2 over here, like so, and that's ready. Okay, so now all the logic has been built. Now we can actually get to the fun part, which is building the graph itself. So I'm going to say graph, and this is basically just going to be a state graph, like that. We're just calling that, which we imported earlier from LangGraph. And then in here, we're going to just add an agent state so that LangGraph now knows what it should expect for the states. Cool. Now, what we're going to do is we're going to say graph.add node. Okay. And this node is going to be add node 1. And then we're going to go ahead and add, or actually it will be add node, just add node, because I want to just keep the same names that have been defined over here. And that's just gonna call add node 1 like that, right? So the next parameter is just the function which the node will call. Because remember, if you recall from my Instagram reel, if you've watched it, I've talked about this, and I've said that a node basically facilitates the task, right? It runs and manages the tasks which are required within the graph. And so this is just one specific node, so it just does one specific task, which in this case is adding. Okay. And so we're going to do the same thing now for the subtract underscore node. I'm just gonna go ahead and copy this and paste it. I'm gonna just put in some space. I'm gonna put this in a new code block just for organizational sake. But this is gonna be node 2, and then obviously we have to change our function to be adherent to that logic, like that. This should be node 1 though, right? Yeah. Okay, so I'm just gonna go ahead and delete this and just paste it in a new code block like that. Before I run these though, one thing that is missing is I have to add another node, and this node is going to be the router, right? Now the router has a very special way of doing things, okay? The router, you're not going to actually add any logic here. All you're going to do is add something called a pass-through function. And the reason for that is because you're not actually updating the state, right? If you look into the actual contents of the decide next node, which would presumably be the logic for the router function, you're not actually doing anything related to the state at all. So when you're actually building out the conditional graphs, and you're building these nodes which facilitate the conditions within the add node function, you're just going to create this logic, which is lambda state. like so. All right. Very, very simple. Okay. We're going to go ahead and do the same exact thing over here, right? But in this case, we're going to obviously have router 2. I'm going to go ahead and run this. I'm going to go ahead and run this as well. We have all of our nodes. But right now, we don't have this graph. All we have is this graph, but without these lines, essentially, right? Because we do not have any edges which connect these nodes together. Right now, it's just these nodes are floating in space, essentially, right? They're not actually connected, and therefore you can't have an execution. So let's actually build the edges now and connect all these nodes that we've created, and therefore connect the logic which we have built from the top, right? From before. Cool. So we're gonna start off by doing a graph.addEdge, and in this case we're gonna do a start, and it's gonna be the router, right? The first in the add edge, the first thing that you pass in is gonna be the first node that you want, and then its relationship with another node, or its connection, I should say, to another node, which is router in this case. So start will run, and then only after that, it'll be passed down, like the execution will be passed down to the router. That's what this says. So it's very intuitive, right? You should know that this will be the first node that will run, and then this will be the second node that will run because of the order that we've placed them in. Okay, let's go ahead and add another edge. But this time, we're not going to add any edge. We're actually going to add a conditional edge. Okay, and specifically conditional edges, because if you look over here, after this execution, you have multiple edges that you can go to, right? Or connections that you can go to. You can go to the addition operation edge, because this is the name of this edge, which will connect you to the add node. You can also take an alternative path and go to the subtraction operation edge, which will take you to the subtract node. That's why in this case, we're actually going to be looking at multiple edges and their relationships with multiple nodes. Okay, so the first thing is obviously going to be the router, right? Because we're going to start off from the router, and then the edge is going to move into another node. Then you're going to pass in the logic which will basically decide which edge we go into. And we've already built that logic. It's this one over here. Or sorry, this one over here, not that one. This one that I'm highlighting right now. So all we need to do is just call that. So it's decide next node 1. And then after that, we need, as you can see over here, we need a path map. Essentially, we have called these strings. So remember how I talked about, I'm going to mention like the importance of these strings later on. I'm mentioning them now. These strings will essentially be mapped in a dictionary over here. So the two strings or the two outcomes within this function are addition operation or subtraction operation. And so those are the two addition operation. Those are the two different edges that can be created, or that can be defaulted to. And this basically creates a mapping between those edges and the respective node that should be executed if that edge were to be called. So in this case, if addition and operation edge was called, then obviously we're going to call the add node like so. And if the subtraction operation edge were to be called, then it would be subtract node like so. So that will go ahead and implement the conditional structure into our graph. Now we can move on and do this exact same thing, but for the router 2. So what we will do is we will call. Before we do that though, there is one thing. Yeah, okay. So here's what we're gonna do now. We're gonna go ahead and add 2 edges. Okay, so we're gonna do graph dot add underscore edge, and this is basically just adding connections between add node to router 2 and subtract node to router 2, because these 2 edges should exist, right? They're not dotted like this. You'll notice that these ones are sort of like dotted like this because they're conditional, so it's either or. But in this case, you're gonna add 2 edges or connections between add node and router 2 and subtract node and router 2, and we already know how to do that. So we're just gonna say add underscore node, and then it's gonna be to router 2 like so, and then we're gonna create another edge which is going to be subtract node, and that's gonna be, again, it's gonna go to router 2, right? So this is the starting point, now this is the ending point. So this way we can actually bridge the connection back to router 2, and now we can continue our work from router 2. So within router 2, again, what we need to do is we're at router 2 now. We need to go ahead and implement the conditional edges. So I'm just going to go ahead and copy the same syntax here so I don't have to copy it again. And all we have to do is just change this to router 2, this to decide next node 2, this to add underscore node underscore 2, and this to subtract underscore node and underscore 2, like so. Right? So now we're basically connected all of this logic, or I should say implemented all this logic. And then again, we're going to follow the same exact logic as we did over here and create 2 edges for the end node, which is going to be this syntax over here. So really, it's going to be like this. You're going to say graph dot add underscore edge, and that's going to be from the router 2 to the end. Or sorry, not router 2. Add underscore node underscore 2 to end. But that's not the only outcome that you can have, right? You can also have an outcome from subtract node 2 to end. So you're just going to add that edge as well. So this is the actual graph fully completed, because over here when we created these nodes, you just created them, right? There wasn't no connection. Therefore, an actual graph data structure wasn't built. But this has fully completed that. Now what you need to do is you need to define a variable, you can call it whatever, and you need to just run the compile method. This will allow you to actually build this out, LangGraph to build it out, so that you can actually use that graph. So let's just run this, make sure there's no errors. This doesn't necessarily mean that the graph will work perfectly, because there could be like logic or code errors, but this compile, if it does fail, would most likely be for like syntax reasons. Okay, now we're gonna use something called app.invoke. This will just allow us, again, this app is just the compiled version of the graph, which just means a LangGraph has built it, it's ready essentially to LangGraph. This is what we have right now, right? And so now we can actually use that, and I'm just gonna wrap it in the result variable, and you just need to call the invoke method, as I said, and pass in a dictionary which includes this data. And if you don't include one of these data, then LangGraph will just default to none. So it's fine if you don't include anything, really. Like, it would just say none for everything, right? But we do want to include stuff, and specifically, we want to include the data, right? So it's going to be number 1, which is 10, number, and this needs to be in the proper syntax. So it's number 1, which is 10, which is going to be plus number 2, which is going to be 5, number 3, which is going to be 7, number 4, which is going to be 2, operation 2, which is going to be plus, and then final number 1 and 2, we don't worry about that. All we need are these, because these are the input states, right, that are actually expected by the system. And then once you have that, you can run it like this, or you can actually write it in this syntax as well. Both are equally as valid and correct, whichever one floats your boat. Where you can basically create a new variable called like initial states, and then call the agent state, which is the class that you've built, and then just add in like all of the variables or data, like so. And I actually prefer this way because it just looks more readable. So it's just like for maintainability purposes. But both ways are fine. But I'm just going to use this one. And essentially what you're going to do is, again, you're going to call result and app invoke like so, and then just going to pass in the initial underscore states like so. And let's just keep it like that for now. Again, you could do it this way where you pass in a dictionary like this, but this creates a dictionary for us. It creates a type dictionary for us anyways. And so that's what we're just passing in over here. This just looks more readable and clean to me personally, right? Again, that's just preference. It's not really a big deal, as in what you do. It's a very minor detail. But yeah, just thought you'd know both ways. And then now, all I'm going to do is I'm just going to print the result. And specifically, because this is going to return the state again, and the state is a dictionary, we can, as you can see, we have all these options which are part of the dictionary of the state. We're just going to print 2 numbers, which are going to be the final number 1 and number 2. And when we do that, as you can see, we get an output. I'm going to just delete this. We get an output which makes sense. So that means that all of our logic worked out perfectly. I'm going to go ahead and commit this right now on recording. I'm just going to say add stuff v2. And yeah, you're going to have access to all of this code so that you can go ahead and reference it. And if you want to, change some things, that's completely fine. And shout out to Free Code Camp. I've been using their work, for learning this, and it's very, very helpful. So yeah, good stuff there.